Okay, this is gonna be a quick lesson because we need to move on. I want to make sure that we get through the units. This is 16C, and this is simply taking the first. This is just the first derivative. Sorry. There's a couple of notations for the first derivative. Now, first of all, you know that a function is either f of x or y. So the first derivative, also, derivative, you might see, slope of the tangent, slope gradient of the tangent. You might see it as f prime of x. You might see it as, dy dx. You might see it as df dx. But when you see these, take the first derivative. Now in the last lesson, we came up with a rule. We proved the rule that for any polynomial y, a n to the x, the derivative is equal to, x to the n. The derivatives bring the n to the front, and then subtract 1 from the exponent. We saw that in a couple of examples. I may teach you it the long way, but you have to know how to do it the long way. Just have in your head. As I said, when we look at test questions, we'll see like once every 6 years this showed up, but it did show up, and it's good to know. Some examples. For example, y equals, x squared. So the derivative is 2x to the first. So we brought the 2 down, and then we subtracted 1 from the exponent. That's it. In other words, let's try, 8x cubed. So what's the derivative? Simply bring the 3 down and subtract 1. Final answer, 24x squared. Obviously, so you need it in the form of like a constant. Maybe there's no constant. An x, once again, we're just doing polynomials today, and raised to a power. It could be any power, so you have to go back and refresh your memories. So if I say, f of x equals radical x, you need to convert that to an exponent, x to the 1/2, and then you need to do basic, third grade addition and subtraction. So what's the derivative? Bring the 1/2 down, x. What's 1/2 minus 1 equals -1/2. -1/2. Know how to manipulate this. So it can be written as 1/2 to the 1/2, or it can be written as 1/2 radical x. Just know how to manipulate it. That's the idea. That's basically it. Okay. The next question is, what happens if I have a polynomial like 5x to the third plus 2x squared minus 8? Well, you just take the derivative of each element. Now I'm gonna write something in here that looks a little weird. And this is gonna come in handy in a couple of lessons, but you'll see what I'm talking about. So once again, I'm taking the derivative of each of the part, kind of like the distributive property. So, but that's the idea. If you have a basic polynomial, you take the derivative of each part individually. So the final answer is what? 15x squared plus 4x. What's the derivative of a constant? Think about this once again. Think about if this is the function 8, what is the slope of all the surfboards? You're like, sorry. Let's use purple. what's the slope of all the surfboards? Well, surfboard, 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 surfboard. All these slopes are 0. The derivative of a constant is 0. So this is y equals 8, and the slopes are 0. Final answer, 15x squared plus 4x. Don't be fooled around. Don't be fooled if something looks a little weird. For example, an example I saw in the Hess book, I don't think I'm asking you this, but they put like y equals like 2x squared minus 8x divided by, radical x. What do? Break it up. Break it up so it becomes 2x squared over radical x minus 8x over radical x. Last thing, same idea. When you get something like this, when they say, y equals, 5 times, x plus, 5 squared. You go, I don't know how to do that. Well, for right now, you expand it out. X squared plus 10x plus 25. 5x squared plus 50x plus 125, and the derivative is 10x plus 50. That's it. This is 16, it's just basically boring repetition. That's 15C. Thank you.